Welcome everyone to this edition of the CSIA Partner Technical Webinar Series. My name is Tony Veroven and I am the CSIA Membership and Marketing Manager. I'm happy to introduce our partners and webinar hosts from Integration Objects. The webinar is titled, A New Approach to Drive Decision Support in Industry 4.0. CSIA is pleased to co-sponsor this educational webinar with our CSIA partner members and valued industry proponents. For those of you who are unfamiliar with CSIA, we are the only trade association focused on advancing the system integration industry. Our vision is to ensure that manufacturing and process industries everywhere have access to low-risk, safe, and successful application of automation technology. To accomplish this, CSIA supports system integrator companies in becoming better businesses. We offer guidance to improve integrator effectiveness with our best practices and benchmarks manual, an open forum to connect and learn with other companies, and opportunities to market within the industry. As our members continue to improve their management skills, they can begin to work toward becoming CSIA certified, an industry standard in business excellence. Membership offers members access to resources needed to attain its business goals. These benefits include networking opportunities at the annual executive conference, marketing toolkits, educational materials, and the Industrial Automation Exchange. These are just a few examples of how CSIA can improve your business, with CSIA certification being the recognized seal of approval. Certification demonstrates commitment to meeting the highest standards for integrator businesses and management. Successful system integration businesses combine technical proficiency with sound business practices. In fact, clients are now seeking integrators with CSI certification alongside of an ISO certification. And what does that mean for our supplier and system integrators and your clients? CSI certification focuses on business practices, whereas other certifications tend to traditionally focus on quality and technical abilities. Clients will recognize certified integrators' commitment to industry standards and business acumen when they see or are certified. Certification also increases the probability of technology being well represented and greatly reduces the risk of project failure. The Industrial Automation Exchange is the premier automation supplier guide featuring control system integrators who provide industrial manufacturing and process automation solutions. This is the first place to search for industrial automation answers and for clients to research technology teams to implement their next automation integration projects. Clients can easily filter to integrators and suppliers based on industry, specialty, products, or locations. They can search for products and choose a supplier's recognized or certified integrator partner. Any company in the automation industry can create a free profile in the exchange. For more information on certification, membership, or how to participate in the CSIA exchange, contact any member at 800-661-4914 or find us on the web, controlsys.org. Thanks so much for attending today. If you haven't done so already, I encourage you to save the date for the 2018 Executive Conference, April 24th through the 27th in San Francisco. Sami Ashur from Integration Objects will be speaking today. Sami is the CEO and founder of Integration Objects and has over 25 years of experience in architecting, developing, and deploying automation, advanced controls, and optimization, artificial intelligence, predictive and prescriptive analytics-based solutions for the process manufacturing industry. Prior to Integration Objects, Sami held several positions from project engineer, solutions architect, to vice president of operations, respectively, at Michelin Tire, Aspen Technology, and GenSim. Sami, thanks so much for hosting this webinar. Take it away.
Well, thank you, Tony, for the introduction, and it's a pleasure today to meet you over the web and give you a presentation on a new approach to drive decision support in Industry 4.0. I'll give the agenda. I'll give just a quick introduction about Integration Objects, justify why Industry 4.0 why there's a thirst to upgrade to Industry 4.0 today on the market. What is Industry 4.0? We'll provide an example as in form of a case study, and we'll introduce our IoT platform. So who's Integration Object? Integration Object is a global company. We're founded in 2002. We're a member of the OPC Foundation. Our business is primarily in the operations, performance management, asset reliability, energy optimization, abnormal condition management. The technology we're providing is primarily focused around industrial IoT, artificial intelligence, predictive, prescriptive analytics, and many other technology that is in complement of the our full solutions. Integration Object has been recognized on many events as a world leader of providing advanced technology, all the way areas from cybersecurity to big data analytics to machine learning and artificial intelligence. So why is Industry 4.0 so important? First of all, there's a lot of competition out there, and industry, their number one obsession today, how to survive, remain competitive, and maintain leadership. So, and most CEOs and management realize the only way to maintain their competitiveness is through technology. So what are the main characteristics of Industry 4.0? First of all, they need to change the way they run their plants. Okay, in the traditional world, a lot of industry has been in firefighting modes, reactive, as opposed to being proactive. So the drive today is to be in run the operation in a predictive and proactive mode. Don't wait until the problem happens. Always be able to predict problems and correct them in advance. So the other thing is optimization. Optimization is extremely important, whether we're talking about optimizing energy consumption, optimizing raw material consumption, or optimizing production. There's competitive industry, they're always on the run to find the best way to produce more at the minimum cost. The other thing is the maximizing productivity and efficiency. And this relates not only to the processes, but relates also to the way organizations are running their operation. So there's a need then to integrate the operation team as part of the automation solution, and how to make them collectively run in an integrated manner and make them efficient and productive. Increasing revenues and profitability is always the key driver, and by following between all these ingredients and ensuring compliance and maximizing the productivity, eventually they'll reach increased revenues and profitability. The other thing is we're trying to make the job of the operations team easier and more comfortable, and easy, quick access to information and traceability is going to be key into running the operations. We're going to see a lot of, in many scenarios, you will see in traditional industry, a quality problem happens, they don't know where it exactly started. So traceability is going to be a key thing. The other thing is knowledge sharing. We all know today that knowledge is really the main competitive ingredient that allows industry to maintain their competitiveness. The more knowledgeable their employees are, the more efficient they're going to be. Knowledge today, the idea of knowledge is to empower all users and make them as knowledgeable as possible, and make them as shareable as possible across the organization, so faster decisions can be made and repeated problems are prevented. The other thing is, equipment, assets are becoming increasingly complex. No one can their downtown anymore. They're maximizing the reliability of the equipment is also going to be key, because what we're finding here increasingly that reliability can impact safety, can impact quality, can impact the processes, can impact your the productivity of your operations. So all of this are the ingredients of migrating today to Industry 4.0. The Industry 4.0 market is today increasing exponentially. We will be the companies that will have digitized will be going digital. Their value chain is going to increase by 80% over 5 years. The investment that's expected between now and 2020 is about $832 billion. They forecast an increasing revenues to the industry in the U.S. alone is about $200 billion, while in Europe it's about 110 billion euros. The incremental value to the global GDP today in the world within 20 years is going to be 10 to 15 trillion dollars. So what is Industry 4.0 exactly? First, we're talking about collaborative robots. Okay, the idea is it's not only related to robots, but every single automation island, or every single sensor, or every single asset is going to be talking to the rest of the asset. So integration and having a collaborative environment is going to be key. And it's not only going to be data, but it's going to be beyond data, what will be exchanged. The internet, the industrial Internet of Things, okay? Every single device will be connected to the network and will be accessible to the users. Big data analytics. Today, we're finding increasingly the need to analyze data. A lot of this industry accumulated years of data, and now they're deciding what they're going to do with it. In fact, one of the big things that's hidden in data is knowledge. So the idea is to extract all of that knowledge out of that data, so mistakes cannot be repeated, previous problems can be predicted. We get a lot more insight from the data of how to optimize the operations, and it gives you a lot of insight even how to perform some design improvements. The additive manufacturing, also it's going to be a key, like a 3D printing, for example. Decision support systems based on knowledge to empower users to shorten significantly the learning curve of the newer generation. The other thing is, by commoditizing, the existing knowledge, you're going to build on top meta knowledge, and mastering knowledge of your operation is going to be what's going to keep you competitive. Cybersecurity is always on the menu. That's an unavoidable aspect to be concerned with and to take that into consideration. And finally, cloud computing. The industry increasingly they are tired of maintaining their servers, their hardware, and they want to outsource this and let it run on the cloud, of course, while taking into consideration all of the cybersecurity aspects. So Industry 4.0 has 4 design principles that need to be taken into consideration. The first one is interoperabilities. Like I was saying a while ago, machines, devices, sensors, and people also, more importantly, need to be connected with each other. Information has to be readily available between all different parties, whether you are an automation island, a device, or a person, or an employee. Virtualization. The systems have to create virtual copy of the physical world through sensor data, so it can be contextualized. And we'll see during the presentation what we mean by contextualization. This is going to be key because by aggregating all that data, bringing it to a single central operating room, that's going to be overwhelming for end user. So contextualization is going to be key how you do it, so you can minimize all these multiple control rooms that are spread throughout the organization. Technical assistance is also another important factor. Decision supports to help human making fast, accurate decisions, and have the ability to diagnose problems in real time rather than waiting until the problem happens and then go through the whole diagnosis process manually and finally take corrective actions. Today, the industry can no longer afford to have downtime or machine breaking down and have unplanned downtime. That's no longer acceptable, and because it simply costs a lot of money and does not make them competitive. The other thing is also decentralized decision making. So empowering remote end users and helping them make an autonomous and not depend on decisions being made from the central control room or from headquarters is also going to be key as it increased productivity and effectiveness. So let's look at just a simple case study here. I have a customer in the lube oil business, had a lot of customer complaints, on a huge shipment more than once, and that costed them hundreds of $millions, and a lot of customer complaints, loss of customers as well. And as soon as that happened, we see revenues going down, and also they were affected on the stock market. So they were in search of a solution, try to find out what the problem was. So there were few symptoms, okay, with the end product that were returned, and one of the key, without revealing who the customer is, without revealing what the exact problems, I'm going to keep it at a high level for confidentiality reasons. But there was a problem also with the viscosity. That was one of the most important issue. There was a lot of brainstorming sessions manually, months and months of discussions internally. And at the end of the day, there was like only one solution which was to take all of that data accumulated during the years where they had customers' claims, complaints, and go over the data and using that data, okay, and a data and a big data analytic solution, we help them identify the exact problems of where the problem was coming from. And in today's systems, it is so advanced, it can literally isolate special patterns and behavior in a cloud of data. It can literally, the systems will allow you to identify exactly what caused this deviation, what caused this isolated pattern, to behave in such a manner. So once the model was developed, to identify what really caused those problems, and by the way, the problem, just to let you know, it was caused by one key process asset, or one key, or I would say process equipment that was impacting the process, and it was also combined with one of their supplier giving them the raw material that has a quality issue. But in reality, they were able to get by when the problem only occurred with one issue, but the combination of both issues caused them to have those problems. So as a result, what we did is we developed the model, and model doesn't mean mathematical models, by the way. Models can be in form of, yes, predictive models based on the sensor data, reading them real time, so we're able to detect the problem in advance. But the model can be in form of rules, can be in form of fault propagation models, it can be in form of machine learning algorithm. So there was a lot of combination of things that were able to prevent those issues in the future, and we provided them a real dashboard that ran in real time and can provide them exactly at the high level there was a quality issue about to occur. So what is the solution we're offering? The solution we're offering is really, it's really in a way, it's a paradigm to Industry 4.0. First of all, the ability to collect every piece of information that is out there spread in the factory. The other thing is to do what you call prescriptive analytics. A lot of times we're talking about just predictive analytics or analytics purely, which means running reports after the fact. Prescriptive analytics allows you to predict problems while running in real time and really identify the exact corrective actions proactively before the issue occurs. So, and that's been done through symptoms detections and many other things. The other thing is the ability to decentralize decision making. Not only allow the folks who are sitting in a centralized control room, but allows also field operators to access that information and take actionable decisions. So all of these elements have been able to empower end users to reach their competitiveness objective. So what is the solution we're offering? We have, first of all, some analytics tools, okay, that allows you to read your massive amount of data that have been historized in your data historian for years. And the idea is to extract knowledge out of that data and significantly reduce that massive amount of data into meaningful knowledge. Knowledge is what you can be expressed in form of rules, like it tells you if you have this symptom, that symptom, then you're gonna face this problem, and that's knowledge. And it can be in form of a predictive models. It will allow you to have all the correlations, which variable impact which quality parameters, what's causing energy consumptions, what's causing abnormal situations. All of that will be generated out of that big data. So in fact, what we're doing here, we're generating also meaningful information. So this KNet Analytics tool and our technology allows you to have a deep understanding of your processes, which will be the step number one if you want to run your operation effectively. You know, there's a lot of hidden knowledge out there in that data. Sometimes we think we know everything about our processes, but sometimes there are things that are really deeply complex and that we take for granted, but they do exist and they have to be taken into consideration. So once we have a good understanding of our processes, one of the first things that we do is to extract that data and deploy them in form of performance deviation models that allows us not to detect complex events, but also allows us to predict performance deviations so we can be proactive about that. So once those performance deviations are detected or predicted, we will notify the right users, but the idea in parallel, we do what you call an automated root cause analysis. Now, root cause analysis is well known to be done after the facts, traditionally. Root cause analysis, like once you identify the problems, once the equipment failed, or once you have a quality issue, traditionally in the industry, they have meetings, they brainstorm, they bring their experts, and they analyze the data manually and identify what the problem is. But during that whole time, during that whole process, the problem is still persisting, okay, and the end user is still losing money. So the idea here is to be able to predict or identify the root cause of the specific problem before it impacts your operation. So once you identify the root cause, the idea is to guide users or empower users to provide fixes, to provide corrective action to that specific problems. And at the end of the day, the end users only sees a dashboard either on their computer screens or either on their iPad or iPhone. It doesn't matter, because the information is available in any manner or form that they wish to have. So what is our approach? Okay, we tell the industry, listen, you have a lot of data, and data today in the industry is in form of typically process tags. So you'll see like tag TIC 101 equal 75.3 or 62.1, TIC 107 is equal 10 or is equal 0.99, and so forth, or whether you're alarm high or low alarm, or high, low, low, and that's a lot of information. That's a lot of data. So the first thing that we do is we take all of that massive amount of data, okay, whether it's coming from your control systems, your PLCs, or historical data, or lab data, or it doesn't matter, and we transform it into complex events or information. Complex events or information is something that human can understand. Okay, I can tell you, for example, you have an energy overconsumption, so you have a drop in the octane number. That's meaningful to end user. But if I keep telling them crunching data, crunching numbers, it's not going to mean a lot, or it's going to take them a long time to figure that out, figure out what it means. So once we detect all of that complex event information, we can analyze the impact of the data. We can identify the root cause of the specific problems. For example, you say you have a process issue or you have an energy consumption. It turns out you have a valve that is being stuck at a high value, and that can impact a lot of things. It can impact all the way to profitability, to quality, to process the services, to even sometimes safety problems. So once you identify those root causes, the idea is to transform that into actionable knowledge, actionable decisions. So then at the end of the day, you can do all the root causes that you want. You can detect all the problems. At the end of the day, what is the best corrective action to take so I can bring my plant operations to the desired performance level. So what is the architecture that we're offering? So we offer 3 tiers architecture. Today, the first level is to collect data from the network, okay, and data can be from a control system, can be from database, can be from sensors, can be from a robot, can be from cameras. It doesn't matter. But the most important thing is we collect all that data into a real-time server, and once that data is collected, what we do is internally we present it to our KnowledgeNet engine, which is our reasoning engine. And in our reasoning engine, we use a lot of technology like the data analytics, like we use AI, artificial intelligence, machine learning. We do workflows, root cause analysis, fault models, and so forth. Okay, that sounds a lot of high tech, but in fact, one of the key elements that we did, or the key ingredient that we did in our technology, we made all of that technology complexity transparent for the end user, and we present it in a very, very simple manner, such as someone just with basic skills who understand how to use a SCADA system or an Excel spreadsheet is able to use the technology. So once that reasoning engine, the data is presented to the reasoning engine, what we have the presentation layer, which is split in two parts. One is the configuration layer, which belongs more to the engineer to configure the application, And the other thing is the customer client application, which is in form of GUI or an HMI, and that can present it to any third-party HMI, whether if you have an existing one, it can be presented SharePoint or a web end user, a web application, or it can be in form of a tablet or an Android or an iPhone. So this is like a typical customer configuration that you have. This is more, we pulled this off an application of an oil and gas customer having some production field onshore and offshore with pipelines, a lot of infrastructure, pulling data from all the different assets, either through fiber optics or satellite communication or GPRS or 4G data communication links, and then transmitted to a centralized control room, and of course with all of the cybersecurity infrastructure, and with end users sitting in their control rooms and as well as in the field. So now the end user is empowered through just simple web portals or simple HMI to be able not just visualize data or our alarms, but visualize meaningful information, like look at what are the opportunity for optimization, visualize the performance, visualize safety data, look at their stocks, and in real time, okay, the system will consider all of these different criteria and be in a mode to be able to drive decisions in real time. So the other thing, so as you know, we covered all different 4 elements of Industry 4.0. So now we covered the interoperability, and now we're going to be talking about the technical assistant, which is primarily referring to the decision support systems. So in the past, okay, users used to pull data just from control systems or historian and look at all that massive amount of data of trying to make decisions and get some sense out of it. Okay, we're saying a little bit of contradictory message to the end user. Okay, on one hand, we're telling them you have too much data, but in fact, we're telling them also you don't have enough information or you don't have enough knowledge. And what KnowledgeNet, the KnowledgeNet platform does, it says, look, Mr. End User, don't worry about the massive amount of data that's out there in the field, okay? I will do that job for you. I'll take the data from all these different control systems, data historian, but also operating manuals, workflows, the results of your data analytics, your root cause analysis report, your KPIs. I'm going to aggregate all of that data and at any one point only present the information that you need. You don't have to worry about all 10,000 data points. The only thing what you have to worry about, what's happening in the process, which would be contextualized and described in English-like language, and provide you with what are the exact corrective actions you need to take so you can bring your operation to the optimum level or to the desired level of operation so you can meet your operations objective. The other thing is that we're saying is, you know, not only plant operators are running the operations, but also engineers are running the operations. Plant manager, operation manager, executive, and each one of them need to have a dashboard by which they can interact with the processes, but every dashboard needs to be customized. It needs to be customized to the user for the information that they require so we can empower them to do their job better every second, every minute, every hour, every day. So now we have a single version of the truth. So plant manager no longer have to rely on manual written reports from the full chain, from the operator to the engineer to the shift supervisor. So all of that reporting, you know, can be automated. Not only can be automated, but it can be done in a very accurate manner. You know, in the past, plant managers or operation managers used to get a report 7 o'clock in the morning when they show up at the plant, and then they look at the report and they see deviation with respect to their KPIs. So they gather all of the different operation members, try to brainstorm what the issue is. But that operation manager got the issue report 7 o'clock in the morning. That means that issue started long before that. Okay, by the time they gather all the different players or the team members and try to brainstorm, okay, that means during that time the problem is still growing, and which means money losses to the industry. And by the time they reach a decision, so the decision is not always being reached in an objective manner. A lot of times the guy with the loudest voice wins in that meeting, and it doesn't mean that is the real problem. And the worst thing you can do, you go correct a problem that doesn't really exist, or correct or put your hands on an asset that does not have any problems. So you end up creating two other problems in addition to the one that already exists. So the idea also is to empower not only in the chain of command from the operators to the executive, but also empower the field operator, and so we can decentralize decisions. So the data has been pulled today from the different assets, of course, through all your cybersecurity criteria, and provide dashboards, and the dashboards will have not only KPI information, but immediate root cause analysis, immediate corrective actions. So now the end users only have to worry about the corrective actions. They don't have to worry about wasting time troubleshooting things that don't even exist, and have all of that information from a single version of the truth that they all can share and take an action on. And not only operators manager, but also remote end users using their tablets or using their iPhones, and the data can be also hosted in the cloud or the whole application, and can be shared seamlessly across the entire organization. So what is our approach? So we have a platform called KNet Analytics. The idea of KNet Analytics is to load all of that historical data you have accumulated in the past and learn from it. And it has, of course, in KNet Analytics, what you will do, you will have all of the different tools to clean the data, generate decision trees, all the regressions, machine learning capabilities, optimization algorithm, identify all the expert rules, derive them from the data, and identify all of that. So basically what you're doing here, you're simply transforming your historical data into knowledge. So once you extracted all that knowledge, in addition to the knowledge that already exists in the plant, the idea is to deploy them online. But before you deploy it online, we do offer what you call some playback capabilities, which allows you, once you have built your application, combined with all these different technology, machine learning capabilities, is to validate all of that against your actual plant data. And that online application, what it will do is collect data in real time and historical data, and run it through the expert rules, through the fault propagation, root cause analysis in real time, and all your predictive models, and empower you through workflows to get some decision support. So at the end, you're going to end up running your operations in a predictive and proactive manner to predict. Don't wait until the failure happens, but be in a position to prevent it. You do the root cause identifications in real time, and you take immediate corrective action so you can maintain the availability of your assets and your operations. So our IoT platform has the ability to pull data from the field unrelated to what infrastructure that you have. And within the IoT platform, as we're not we don't do just analytics because there's a lot of there's a lot of misunderstandings what analytic means. Analytic is becoming like a big word, subject to interpretation. It can be all the way from just doing a simple Pareto charts, which we did in the 1980s and 70s, all the way to do prescriptive analytics. So to be able to take all of that data and through analytic, machine learning and big data analytics algorithm, have the ability to identify literally all the way to the corrective actions. Now, what we've seen us in traditional organization, they typically segregate them between maintenance, reliability, operation, process, and so forth. Now, the IoT platform does not make any segregation. And in reality, all of these different elements, they're all interlinked, they're all related. For example, you talk about, let's say, the reliability of your equipment. Reliability of your equipment can impact your safety, it can impact your quality, it can impact your energy consumption, it can impact the performance of your assets. It can impact many things. It can create emissions issues, pollutions. So in fact, you can no longer segregate all these different parts of the organization because they're all interlinked. And our IoT platform has the ability to generate reasoning on all these different elements. So at the end of the day, the end user has a corrective action. Okay, whether the root causes come from reliability or sensor issue, maintenance issue, or a bad decision from the operator, it's irrelevant. At the end of the day, the most important is you're meeting your production targets, you're meeting your energy consumption targets, your raw material consumptions, and your safety. So that's what I have for my presentation. So what I'm going to do here, I'm going to try to give me just a second to unmute, and I'll be available for a question here. Okay, we have questions here. Okay, let me read the questions for you, and I'll try to answer them. At the same time, please feel free to send us email. How does integration offering differ from the big DCS vendor proposition? Okay, I'm not sure what propositions DCS vendors have. You know, they typically have DCS control system. They have automation PLCs. They have sometimes advanced controls and optimization. What we offer is differently is knowledge-based solutions. Okay, we don't only have our solution is not only based on mathematical models, which is we've seen with history. They work only for a short period of time, but we take everything in a holistic manner. We look at past experience. We extract knowledge out of big data. The DCS vendors don't do big data. They don't do knowledge-based systems. So that's where we offer our combination, where we take all of that into consideration in order to build our applications. So I have another question: is do you have partners to cover all expertise described in your presentation? The answer is yes, we do. We have a very aggressive partnership program. We do recruit a lot of partners, and we like to work with partners. We support them in building their first applications. We provide what you call technology transfer, not only to them, but also to the end user. And we will help them get started on their projects, on their first projects. Do you have references in the industry? The answer is yes. We have several references. We initially in integration objects focused a lot in the chemical, oil and gas sector, but we are diversifying now. We're seeing that we're being solicited increasingly by other industries such as the manufacturing industry, the cosmetic, the food and beverage, and the pharmaceuticals. So we're not limited. Our platform is really generic. It's not limited to the kind of industry we will work with. And our customers have been primarily from the tier 1 customers to tier 2 to even tier 3, but primarily we work initially with the tier 1 customers. Okay, when talking about generation, I'm asking a question here. When talking about generation, for instance of expert rules or RTA, how much effort is required by engineers? Is the process fully automatic? Okay, now first, okay, you have two big values, okay, that we offer. You have the ability to extract rules out of your data, and that's we can send you demos, demonstrations, and to show you how to do that. It's not difficult. Okay, it's it takes like 2.5 days of training, and we will show you videos how you're able to extract data rules from data, and also root cause analysis. And the other thing is our rules, by the way, they're configurable graphically, and as well as our fault propagation root cause analysis. It doesn't take a rocket science to configure them. But however, it requires a deep understanding of your process. And to have a deep understanding of your process, you have several sources of information. First of all, your data analytics. Okay, our data analytics platform is going to help you develop that deep understanding of your processes. The other thing is, most customers sometimes don't realize that, but they also have a wealth of knowledge about their own process. So what you need to do is also take into consideration your own knowledge, the knowledge of your colleagues, of your internal expert, and as well. And we've seen a lot of systems integrators with very strong knowledge as well, and they will help you structure that and deploy that online. And also, we're also open to working with any of your the end user. A lot of times they have their local systems integrators they like to work with. We're also open to work with them, even if they're not an existing partner. We'll recruit them, train them, do technology transfer, and build the methodology, transfer the know-how to build these kinds of applications to them. Okay, I have more questions here. Let me read them for you. Do you require a minimum of instrumentation to ensure observability? Yeah, there's always a minimum of instrumentation that you would need, right? You need minimum of data, but a lot of times, okay, so this is coming from if you look at the traditional world of providing models that are based on specific instruments, and if you don't have those instruments, that means you cannot run the models. Now with us, it's different because you can build your analytics models based only on the existing data. You don't necessarily need all the instrumentations like the traditional systems. Now, there will be time where the engineers can identify a hole in the instrumentation, and that does happen, and they will recommend, say, okay, Mr. Customer, if you want some real in-depth information about the specific processes, you need this additional instrument to be able to achieve your objectives. So that's and what's good is in the data analytics, it can also help you uncover holes into your instrumentation implementation. I have another question here. I wonder how many years it take in a complex refinery to implement the whole range of your technologies. I'm not speaking about the budget. Okay, well, On refinery, on a specific refinery, if you look at refinery, of course, it's one of the complex processes. Let's say you talk about a process unit like a CCR or a crude unit. Okay, it takes about to do a full implementation of the entire project will take about I would say 6 months, but also that depends on the region where you're running from the time. And this is, by the way, that 6 months is not the fingers that you put on your computer to configure the application. That whole time to configure the application between the testing and the configuration is only 2 months. The other 4 months is more writing the functional design specification documents, having alignment with the end user, you know, doing the testing, the documentation. This is what consumes most of the time. I have a question about this, whether a specific customer is using our product. Okay, I cannot reveal the name of specific customers who are using those products for confidentiality reasons. But we can talk about that on a one-to-one basis. Okay, we have time for one more question. Otherwise, I will call this meeting to an end. And I'd like to thank all of you for attending the presentation. And please feel free to send us any questions you may have, and we'll be happy to address them. So thank you again for logging in today. And we hope to hear from you at your convenience. All right, bye-bye for now.